Alright, so the 2.3 is the linear function and the slope. So basically, we need to know how to find the slope. Okay, using the point slope from the equation, how do you find the vertical line, horizontal line slope, how to graph them, right? And then how do you find the model, using the linear function, make a prediction. So a little bit application in that case, okay? Alright, so we talked earlier, slope is usually called changing the x, changing the y over changing the x, or called the rise over run, right? If you do the high school algebra 2, that one, you should have this one, right? Rise over run, or you can just learn it the first time, that's fun. Alright, so we're using y2 minus y1, so this is the rise, okay? Going up, that's the rise, and then the horizontal is the run. So the vertical one is y2 minus y1. The horizontal one is using x2 minus x1. If x2 minus 1 minus x1 is not equal to 0, this will be different, right? So that is how you find the slope in general, okay? So look at this one right here. If I have these 2 points, how do I find the slope? Okay, so I can usually mark the x1 y1 in here, x2 y2 in here. This sounds pretty simple, but you're marking this one so you don't make mistake, right? Otherwise, some people think this is x1, this is x2, which is wrong, right? So your y2 here will be 5 minus y1 here will be negative 2, right? x2 here is negative 1 minus x1 here is 4. And then we just do a little bit calculation, okay? So 5 minus negative 2 will be plus 2, and then this will be negative 5, right? So this will be 7 over negative 5, or you can just write down negative 7 over 5. Alright, so that's the slope, right? So this formula is a general formula to find the slope for the linear, okay? That's the line, alright? Okay, if we want to find the equation, we have to using the slope, find the slope first, and then using one of the point, okay? One of the point called x1, y1, and then this is the linear called the slope point or point slope form, okay? Instead of using y equal to mx plus b, this is called a slope intercept. This is a slope intercept form, right? But this one is much easier because you don't have to find the b separately. You can just plug it in and find the equation, okay? Alright, so look at this one right here. If I want to find this equation, slope is 6 and then passing this point, right? So I just write down this slope point equation in here. And then this is my x1, y1, okay? Alright, so y minus y1 will be negative 5. Slope here is already 6. And x minus x1 here is 2, right? So that is my equation. So I have this plus 5, and then this multiplied in 6x minus 12. I minus 5 on both sides, so my y here will be 6x minus 17. So this is my equation, okay? So look at this one right here. That's very easy to write. Alright, you can using the y equal to mx plus b called the slope and y-intercept to solve. But this one we have to using the point to find the b first, alright? Using this method is I can directly plug into the equation and then simplify. I can get a slope point formula, okay? Alright, so look at this one right here. How do I graph this function? Okay, so look at this function here. This actually is y equal to 3 over 5x plus 1 if you want to use this one, right? And you can calculate 2 points. I usually just calculate x and y, 2 points. So I write x equal to 0, right? When x is 0, f of the 0 will be 1, right? Because this whole thing will be 0, so y will be 1. So you have a 0 and 1 in here. So this point is 0, y is 1, Okay, so I only need one point. So how do I choose the other point? I don't want to choose x equal to 1 because I'm going to have a fraction. So instead of 1, I choose x equal to 5. Look at it. So how much is f of 5? That's 3 over 5 times 5 plus 1. 5 and 5 cancel out, so this will be just equal to 4, right? So when x equal to 5, this will be 4. 1, 2, 3, 4, right here. All right, and I just connect these 2 points together. Okay, and then extend the both sides. Extend the both sides, and that's it. That's how you do the graphing. And of course, you can put in a calculator and double check that, right? But that is how you do the graphing by hand. All right, and this is called the rise and the rent. Okay, this is using rise over rent to do the calculation, and sometimes it's, you can say, okay, from this point, right, and I go up for 3 units. So this is 1 plus 1, 2, 3, 4. So go up for 3 units. So that's go up for 3 units, and then going to the right for 5 units. So 1, 2, 3, 4, 5 will be right here. So actually this is the point 5 and 4. All right, so if you want to consider the rise over rent that way, but I usually just go ahead and calculate this point is much easier, more intuitive, actually more intuitive. Okay, otherwise you're going up 3 points and then moving right for 5, so that's 3 over 5. Okay. All right, if you have a y equal to b, that is considered a horizontal line. Okay, b can be any constant number, like I said, y equal to 3. Okay, how do you graph y equal to 3 without x? Well, that means x can be any number, right? So 1, 2, 3. X can be any number. Y is always equal to 3. So that is the horizontal line. Okay. And then, you can have x equal to any point, right? X can be -2, can be 0, can be +2, and y is the same. Okay, so that's a horizontal line. If you have x equal to a, that's considered a vertical point. So for example, x equal to 2. So y is not on the picture, right? So that's 1 and 2. All right, so x is always 2 regardless y value. So y can be 0, y, x, y, 2, 0, 2, 2, 2, whatever. Okay, maybe this is 4. All right, so whatever the y value is, x is always equal to 2. So that is this one, 2 and 0, and then 2 and 2 will be right here. All right, 2 and 4, 2 and 4, 2, 4, okay, right here. All right, so that's a vertical line in here. Okay, so how do I find a slope? Okay, this is called a general form. So what is a general form? We have a slope intercept form, right? If you write down y equal to mx plus b, that's called a slope and the intercept form. And if you write down the ax plus by plus c equal to 0, this is called a general form. This is still a linear function or still a straight line. Okay. Alright, so if I want to find a slope from this general equation, what do I do? Well, I have to go to find a y equal to mx plus b form in order to find a slope. Okay, so that means I'm gonna have to move everything to the right. Alright, so look at it. I have a 3x plus 6y minus 12 equal to 0, right? I have to move 3x to the right hand side, and I'm gonna add a 12 on both sides, so that way I can cancel this one out, I can cancel this one out, so I only have a 6y left. Okay, and then 6y 0 minus 3x, so that's negative 3x plus 12. Alright, and I just divide by both sides by 6, so this cancel out. So I have a y, and then each one divided by 6, right? So this will be negative 3 over 6x plus 12 over 6. Okay, and then simplify, so that's negative 1/2 x plus 2. Alright, so now I have this one called y equal to mx plus b form, my m here is negative 1/2, and my y-intercept here, or b here, is 2. Okay, so this is just the way. If you're giving you this form, you're gonna need to be able to transform into the slope-intercept form. Same thing, if I have this slope-intercept form, I can transform into general form as well, right? So you just do the opposite way, and you will get back to here. All right. Any questions? I want to see if any questions so far. Anyone has any questions? Okay, you can do the chat right here, or you can just unmute yourself and talk. Okay, or you can type it in the chat here. All right. Okay, using the intercept to find a linear equation. Okay, so how do you find the intercept? Look at that. If you want to find the x-intercept, you let y equal to 0, solve for x, right? If you want to find the y-intercept, you let the other one. So where's the other one? Let x equal to 0 and then solve for y. Okay, so that is how you find the intercept in here. Alright, so how do I find my x-intercept in here? Let y be 0. Okay, let y be 0. So y is 0. This is 3x minus 2 times 0 minus 6 equal to 0, right? And 2 times 0 will be 0. Alright, so I have a 3x minus 6 equal to 0. I add a 6 on both sides. So I have a 3x equal to 6 divided by 3. Okay, so x will be equal to 2. Alright, so the x-intercept is 2. The point, the order pair will be 2 and 0 because y is 0. So if I graph this one, how does that look at that? Well, x equal to 2, okay, 1 and 2, y is 0 right here. Okay, and if I want to find the y-intercept, what do? I let x equal to 0. So x equal to 0, this will be 0. Alright, so I only have a negative 2y minus 6 equal to 0. Okay, I can add a 6 on both sides. Alright, so this cancel out. Negative 2y equal to 6 divided by both sides by negative 2. Alright, so y will be negative 3. So when x is 0, y is negative 3 right here. X is 0, y is negative 3, and then just connect these 2 points together is standard day. And that's it. This is done. Okay, we call it done one. Alright, so that's how you find the that's how you find the x and y intercept, and then just using these 2 points to graph. Okay. Alright, so that's the graphing in here. Alright. The last question here is consider the application. Okay, so if we have these 2 data points to obtain a linear function that models average global temperature, okay, and then this temperature is f of x. For an atmosphere carbon dioxide concentration of the x part per million, okay, long m to the 3 decimal point and b to 1 decimal point. Alright, so how do we do the modeling in here? Well, if we want to do the linear, right? In linear, we can use y minus y1 equal to m times x minus x1. I can let this one is x1, this one is y1, this is x2, this is y2. Okay, and then first we have to find a slope. So this is the slope, right? y2 is 57.64 minus y1. This is y1. Okay, and then this is x2 minus x1. Alright, and then you can go to print a calculator, run to m. This m need to run to 3 decimal places, right? So we can put this one in a calculator. Okay, we can go to the calculator and make sure you use the parentheses if you do those all at once, right? 57 minus 57.04 divide. If you put it in a anytime when you have a two number, you always have to use the parentheses. Okay, parentheses, and then round to 3 decimal points. So you have to look at the fourth point. This is 2, so you round it down, right? So this will be 0.016. All right, we look at the fourth digit is 2, you round it down. If this is 5 or above, you need to round up. Okay, so I keep 3 decimal point. All right, we want to write down B. Okay, so I can go to find a B, or I can just write down this one. Y minus y1. Y1 is this one, 57.04 equal to m times x minus x1, right? X1 is 317. All right, so this will be 0.016 minus this one will be 0.016 times 317, right? So that is 5.072. All right, so we're gonna add a 57.04 on both sides. Okay, so y here will be 0.016, and then add this one right here. Okay, so these two will be all cancel up. So we have a 57.04 minus 5.072. All right, so we want to round to 1 decimal point, right? B is only round to 1 decimal point. So 1 decimal point, you look at the next digit. Next digit is 6, so you need to round up. So basically, this is just plus 52.0. Okay, you estimate this one, 52 point. So that is our model, right? This is our model. Y equal to 0.016x plus 52.0. So that's the model for the carbon dioxide in here. Alright, so that is our section 3 already, okay? Last section I want to talk today here is more on slope. And then next weekend we will do the review for the entire chapter, okay? So we do have a little bit time. We go through this section by section in detail. I think we have a couple more sections for this, but we will only talk this 4 sections. Alright, so this one you want to look at the parallel slope, okay, for the line. Write down the equation of the line that parallel to this one and passing this point. Okay, so when you have a parallel to this one, what does parallel mean? Parallel means the slope will be equal. Okay, when the lines are parallel, m1 will equal to m2. Alright, so if you go to write down this y equal to mx plus b, my m here will be 3. Okay, so since parallel to this line, so your m here gonna be 3. And then you're using this point, y minus y1 equal to m times x minus x1. So now you have this is x1, this is y1, okay? And then plug it in, y minus 5 equal to m times x minus x1, which is -2, right? And then you do a little bit of a clean up in here. So you will get a y equal to 3x plus 11, okay? So the key thing here is you have to know when the two lines are parallel, their slope is the same. That's the key thing, okay? When the two lines are perpendicular, so what does perpendicular mean? That means the intercept at 90 degrees, all right? So if this is M1, this is M2, we know two lines are parallel, m1 will equal to m2. But if two lines are perpendicular, m1 times m2 will equal to -1. Or you can write down m1 is -1 over m2, or m2 equal to -1 over m1. But I usually don't like these two equations, right? Because if I remember this one, I can get to the other two very easily. So I don't have too many to remember. I just remember the product. The product of these two slopes will be -1. Okay, that's when they are perpendicular. Okay, so look at this one right here. How do you find a slope for the line that is perpendicular to this line and the equation is equal to that? Alright, so since we have the other one is perpendicular to this one, so as long as I can find a slope for this one, I'll be able to find the perpendicular slope. So the step 1 in here, I have to write down y equal to mx plus b, so I can write the slope form, right? So we have to isolate y by itself. Okay, so how do you do that? Well, you have this one right here, you minus x on both sides, minus x, and then plus 12, right? So this cancel out, this cancel out. So you're going to have a 3y equal to -x plus 12, and then divided by both sides by 3. Okay, so now you have a y equal to -1/3 of x plus 12 divided by 3, so you got a 4, right? So now you have this m1, is -1/3. Okay, and then where's my m2? Since this one is perpendicular, so my m2 will be -1 over m1. Alright, or m1 times m2, m1 is -1/3 times m2. This should be -1, and you solve for m2, right? You solve for m2. So m2 here, we're gonna multiply both sides. We're gonna multiply both sides by whatever. By -3, right? By -3. Okay, multiply both sides by -3. Alright, so -3 times 1 will be +3, and then this -3 and this cancel out. Alright, so that's how you find a perpendicular slope. So basically you have to write down this one into y equal to mx plus b form, so you can find the m. Okay, alright, a little bit application. Slope is rate of the change, right? So look at this one right here. In 2019, 11.9 million young adults live with their parents. In 2017, 22 million of young adults live with their parents. So we are not making any progress, basically, right? So from 2000 to 2019, we're going backward, that kind of thing. Use this information to find a slope of the linear function represented young adults living with their parents. Express the slope correct to 2 decimal point and interpret that to see what it represented for, right? So you have to write down in the order pair. So order pair, this is x1, y1, this is x2, y2, okay? And then we're gonna find a slope. So slope is y2 minus y1 over x2 minus x1, right? So we have a 11.9 minus the other way. Okay, so we have a 22.0 minus 11.9, and then this will be 2017 minus 2000, right? And then this will be 17 in here, and then this one, you can go to do a little bit, 11.9, right? So that is 0.1, and then 10.0, okay, 10.0, and then you just go to estimate this one, okay? And then we're gonna using y minus y1 equal to m times x minus x1. All right, and then use this one. y minus y1, so y minus y1, so that's minus 11.9 equal to m. M is, we're gonna estimate this one into a, like I said, 1 decimal point, okay? So 10.1 divided by 17, right, to see what we get. All right, we can run to 3 decimal point, which is very accurate, okay? 0.594. All right, so I can have a 0.594 times the x minus x1. X1 here is 2000. All right, and then we just multiply it in, and then you can go to, write down y equal to 0.05. I'm sorry, not 0, just 0.594x, right? And then just multiply this one in at 11.9, so you can calculate this one, and that is the model in here, okay? So that is actually it's correct the slope into 2 decimal point. All right, so now I have to read we said it earlier, we have to read the description carefully, right? So this one is at 2 decimal point. All right, so 2 decimal point, this will be round to 0.59. All right, so follow the requirement, okay? So just 2 decimal point. All right, and then you can just go to calculate the rest in here, and that is the model in this kind of situation, okay? All right, so we basically went through all the 4 sections this chapter, okay? We go through the very detailed section by section, and next week we will just review the entire chapter, okay? So hopefully you will start chapter 2 after you finish the chapter 1 test, okay? All right, so